Hello everyone, welcome back to my YouTube channel. Today let us discuss about the superposition theorem, which is one of the topic in network analysis. So the first is statement. The superposition theorem states that in any linear bilateral multi-source network, the response in any branch is equal to the algebraic sum of the responses obtained by considering each source acting separately by making all the sources set equal to 0. Proof. Consider the network as shown. Here the circuit consists of voltage source and Z1, Z2 and Z3 and the current passing through the circuit. So if we have to find the current source, we have to apply KVL to the circuit. To apply the KVL to the circuit, we have to consider the number of possible loops in the circuit. In this circuit, we have two loops, that is loop 1 and loop 2, and we have to pass the current source I1 and I2 in clockwise direction. So after that, we have to apply KVL to the loop 2 and loop 1 separately. The first is apply KVL to the loop 1. So after applying, we'll get Z1 I1 plus Z2 I1 minus I2 equals to V. So that is Z1 plus Z2 into I1 minus I2 into Z2 equals to V. But I2 is equals to I. So after substituting the value of I2, we'll get Z1 plus Z2 into I1 is equals to V plus I into Z2. So after this, I1 is equals to V plus IZ2 divided by Z1 plus Z2. So we will be considering this equation as equation 1. So we know that from I2 is equals to I, from loop 2, Ix is equals to I1 minus I2. So because Ix is passing between loop 1 and loop 2, and we will be considering this as I1 minus I2. So after substituting the values of I1 and I2, we'll get V plus IZ2 divided by Z1 plus Z2 minus I. And we after by taking the LCM, we'll get V plus Z2 I minus Z1 I minus Z2 I divided by Z1 plus Z2. So Z2I and Z2I will be get cancelled, and after that V minus Z1I divided by Z1 plus Z2 is equals to Ix. So we will be considering this equation as equation 2. So we have to verify the equation 2 by superposition theorem. To apply superposition theorem, consider one source at a time. So we have to consider two cases. In case 1, the voltage source we should be considered and the current source should be set to 0, that is open circuiting it. So here the voltage source will be considered and the current source is 0. So we'll get an expression like I dash is equals to V divided by Z1 plus Z2. So in case 2, we have to consider the current source and we have to make the voltage source as 0, that is short circuiting it. So by using the current division rule, we'll get I double dash is equals to Z1 divided by Z1 plus Z2 into minus I. So according to the superposition theorem, the actual current, that is Ix, is equals to I dash plus I double dash. That is because the total current is equals to the sum of current sources which are acting separately. So after substituting the values of I dash and I double dash, we will get V divided by Z plus Z2 minus Z1 into I divided by Z1 plus Z2. So after this, we will get Ix is equals to V minus Z1 I1 divided by Z1 plus I2. So we will be considering this expression as equation 3. As we can see, the both equation 3 and equation 2 are same, and the superposition theorem is proved. So we will be solving the problem which is based on superposition theorem. As we can see, the circuit consists of 3 loops and we will be passing the current sources I1, I2 and I3 in clockwise direction. So first we have to apply KVL to the all 3 loops separately. So first we have to apply to the loop 1, that is minus 2 plus 2 I1 plus 12 into I1 minus I2, that is equals to 0. So minus 2 plus 2 I1 plus 12 I1 minus 12 I2 equals to 0. So 14 I1 minus 12 I2 is equals to 2. We will be considering this as equation 1. And next is to apply KVL to loop 2. So 12 into I2 minus I1 plus 12 I2 plus 2 into I2 minus I1, that is equals to 0. So 12 I2 minus 12 I1 plus 1 I2 plus 2 I2 minus 2 I3 equals to 0. So minus 12 I1 plus 15 I2 minus 2 I3 is equals to 0, and we will be considering this as equation 2. And next is to apply KVL to loop 3. So 2 into I3 minus I2 plus 3 I3 plus 4 is equals to 0. So 2 I3 minus 2 I2 plus 3 I3 is equals to 4, that is equals to minus 4. And then 5 I3 minus 2 I2 is equals to minus 4, and we will be considering this as equation 3. After getting all three equations, we will be writing this all three equation in matrices form. So after writing in the matrices form, we will be calculating the values of I1, I2 and I3. That is, I1 is equals to 0.167 and I2 is equals to 0.029 and I3 is equals to minus 0.78. So after calculating all these three, we will be calculating Ix. That is, Ix is equals to I2 minus I3. This is because the Ix is passing in between I2 and I3, that is loop 1 and loop 2 and loop 3. So and I2 is positive and I3 is negative because I2 is passing in the same direction, whereas the I3 is passing in the opposite direction. So after substituting, we will get Ix is equals to 0.809. So now we have to consider two cases, whereas the first case we should consider 2 volts and short circuit the 4 volts. This is because the circuit consists of only 2 voltage circuits and there is no current sources. So after considering this, we have to apply KVL to the loops. So first we have to apply KVL to loop 1, that is minus 2 plus 2 I1 plus 12 into I1 minus I2 equals to 0. So 14 I1 minus 12 I2 is equals to, that is equation number 1. So after apply KVL to loop 2. So 12 into I2 minus I1 plus I2 plus 2 into I2 minus I3, that is equals to 0. So minus 12 I1 plus 15 I2 minus 2 I3 equals to 0, and this is equation 2. And the next is to apply KVL to loop 3. So 2 into I3 minus I2 plus 3 I3 is equals to 0. So 2 I3 minus 2 I2 plus 3 I3 is equals to 0. So 5 I3 minus 2 I2 is equals to 0, and this will be equation 3. So after getting all three equation, we will be substituting all three equation in matrices form. After this, we will be calculating the values of I1, I2 and I3. So I1 is equal to 0.51 and I2 is equal to 0.43 and I3 is equal to 0.17. So after calculating, we will calculate the value of I dash, whereas I dash is equal to I2 minus I3. This is because the I dash is passing in between I2 and I3, that is loop 2 and loop 3. So I dash is equal to 2.43 minus 0.17, that is equals to 0.26 amps. So the next will be case 2. So here we have to consider 4 volts and make the 2 volts as short circuit, that is equals to 0. So after this, we have to apply KVL to all three loops. So the first is to loop 1, that is 0 plus 2 I1 plus 12 into I1 minus I2 and equals to 0. So 2 I1 plus 12 I1 minus 12 I2 is equals to 0, that is 14 I1 minus 12 I2 is equals to 0, that is equation 1. And apply KVL to loop 2. So 12 into I2 minus I1 plus I1 1 I2 plus 12 I2 minus I1 equals to 0. So 12 I2 minus 2 I2 plus 1 I2 plus 12 I2 minus 2 I3 equals to 0. So 15 I2 minus 12 I1 minus 2 I3 equals to 0, that is equals to equation 2. So the next is to apply KVL at loop 3. So 2 into I3 minus I2 plus 3 I3 plus 4 equals to 0. So 2 I3 minus 2 I2 plus 3 I3 equals to minus 4. So 5 I3 minus 2 I2 equals to minus 4, and this will be considered as equation 3. After getting all three equation, we will be writing all three equation in matrices form. So after writing in the matrices form, we will be calculating the value of I1, I2 and I3. So that is I1 is equals to minus 0.35, I2 is equals to minus 0.40 and I3 equals to minus 0.96. So after calculating this, we will be calculating I double dash, that is I2 minus I3, because I double dash is passing in between I2 and I3, that is loop 2 and loop 3. So I2 is positive and I3 is negative because I2 is flowing in the same direction of I double dash, whereas I3 is flowing in the opposite direction of I double dash. So we will get that is minus 0.40 minus of minus 0.96. So we will be getting I double dash is equal to 0.56 amps. And thus by superposition principle we have Ix is equals to I dash plus I double dash. This is because the total current is equal to the algebraic sum of the current sources which are acting separately. So by substituting the values of I dash and I double dash, we will get that is 0.26 plus 0.56 equal to 0.28 amps. So therefore the superposition principle is satisfied. Thank you.